All right, so suppose you're given the function f of x equals to x cubed minus 3x plus 1, and you are asked to find the equation of the tangents with gradients 1. So they're telling you that the gradient of the tangent is 1. And that's the first question. So that's question A. And in question B, find the normal for each of the following, for each of the above equations, for each of the tangents. So in this question here, let's see if we had to solve this. The first thing is I'm going to get a quick glimpse, I'll just give you a quick glimpse of how the graph would look. All right, so that's more or less the curve over there. And so the graph would look like this. And it would go up like that. And that's the equation y equals 3x cubed. Y equals x cubed, minus 3x plus 1. Now, if I have a tangent to this, and it has to be a gradient of 1, you can see I can have a tangent over there at some point, and I can have another one over here at some point. So there's two possible tangents. Now I want to find the equation of each of these. This one will have a y-intercept in the negative, and this one will have a y-intercept in the positive. So that's the first thing. And once I've found each of those, so let me just draw another one. So if I draw two of those, I want to find both the equations of the tangents at some point, somewhere. I want to then find the normals. The normals is the one that goes perpendicular. So that's going to be that normal there. And there'll be another normal just around here coming through there. Yeah. That's cool. So 3x squared minus 3, good. And that's the derivative, right? So you just found the derivative of it. Excellent. So that's going to...
I substitute.
That's it, yeah. And now what do? Yeah.
I substitute the gradient. Wait, no. I substitute.
So basically, because they've given you the gradient of 1, we're going to change this. Remember, the gradient is that now, that value. So we're going to make...
Oh, that's right.
Yeah, so we make that equal to 1. And we're now going to find x, right? All right, I'll solve this one, and then I'll give you another one to try.
Okay.
All right, and this will be 4 equals 3x squared, and I divide both sides by 3. And I get x squared equals the square root of 4 over 3 plus minus square rooting both sides. So there I divided by 3, 4 divided by 3, square root both sides, put a plus minus. So x will equal 2 over root 3, negative or positive 2 over root 3. So that means that we have some x value over here, which is negative 2 over root 3. And we have another x value over here, which is positive 2 over root 3. And so with that, we basically now need to get the y values, right? And in order to get the y values, we can substitute it back into the original function and get the corresponding y values. Will that help us? Because that can get us the c value for our equation for the tangent. Now we know the first part about tangent. The indicator is that we know that the tangents have gradient 1. So the equations are definitely y equals 1x plus some c value.
Mm-hmm.
So I know the coordinates for this is now negative 2 over root 3 and some y value, which I'm going to find. And I know this coordinate over here is positive 2 root 3 and some y value. So if I have those, I can find each of the corresponding c values. So let's go ahead and let's see if we can find each of those y values on this side here. So I'm going to substitute it in and I'm going to say, well, in the original function, if I go back to the original function, I've got y equals to x cubed, so that'll be 2 over root 3 cubed minus 3 times 2 over root 3 plus 1.
Wait, why is it cubed?
It's a cubic function. That's how we derive it, right?
Oh, that's right,
Yeah. So then I put this on the calculator. Probably, well, let's see if we get a nice fraction. If not, otherwise we'll just use a decimal. So 2 over root 3, I'm just typing it in the calculator now. And it is cubed minus 3 and fraction button 2 over root 3 to the power of 1 plus 1. Right at the end becomes negative, so this y value will become negative 0.9, yep, so it's going to keep it in decimal, 0.9245. That looks like this one over here, negative 0.9245. Okay, I'm going to just make some space there. I'll just throw an arrow there. So this one here is going to be negative 0.9245. And now I'm going to change that. That's the one y value. The other y value, we simply just put a negative in front of the substituted value in this. And plus 1 right at the end there. So I'm going to just keep this on the calculator to save time. Handy. Change the negative in the bracket carefully so we don't have to waste time typing it again. And that comes to 2.92, as we expected, would be in the positive space. 2.9245. So that gives me those two values over there. So that's going to be 2.9245, and this is negative 0.9245 over there. And I now have enough information to find each of the corresponding c values. So let's go ahead and try and find each of those c values. We know what the coordinate is. Let me see if I can write it down here. So we got the first coordinate is negative 2 root 3 and 2.9245. And the second coordinate was, when I made it into a plus, let's just make sure we got that. That's going to be negative 0.2 over root 3, and that comes to negative 0.9245. And for each of this, I have an equation, y equals 1x plus c, y equals 1x plus c, and now I simply want to find the c value. Okay, so here we go. 2.9245 equals 1 multiplied by negative 2 over root 3 plus c, so all I've got to do is subtract that. That will be 2.9245 plus 2 over root 3, which will be 4.0. So c equals 4.0792. My final answer, y equals 1x plus 4.0792. And that's the y-intercept. And this is my tangent function. Likewise for this one, substituting negative 0. Now this is just simply substitution, right? So nothing crazy. It's all just simple equations. This is going to be 2 over root 3 plus c, negative 0.9245 minus fraction button. Keep an eye on this. I'm going to give you the next one. You're going to try and solve this with minimal error, right? So the biggest problem with these, when you get to this point in an exam, is that you're rushing and you end up making careless mistakes, but especially the easy stuff. And it's a weird thing, but it happens all the time. So 1x minus 2.0792, and this is the second tangent the one at the bottom. And now I'm going to use this and get my normals down. So looking at the normal part now, let's see, I got each of these. The first equation was y equals to x plus 4.0792. And the point was 2.9245. And negative 2 over root 3. And I'm going to use this now to get the normal. But we know that the normal is perpendicular. If I go back to the original, this normal over here is going to be y equals negative 1x plus c, going through that same point. And this one over here is going to be y equals negative 1x plus c, going through that same point over there. So I need the 2 points, and I just need a negative 1 gradient, because perpendicular gradients multiply to become negative 1. So y equals negative 1x plus c. And now I'm repeating that entire process, but this time I've got a negative x there. So 2.9245 equals negative 1, negative 2 over root 3 plus c. 2.92. I'll try and do this in good speed for practice. And 2 over root 3. And it is a big time waster because it's stuff you know, but you have to do the grind. So 1.7697, 1.76, let's keep it to two significant figures, 1.77. Let's just say 1.77 now. And we'll end up with y equals negative 1x plus 1.77. Let's see, that looks correct. Negative 1x plus 1.77, so that's 1.77 there. 1.77 is my c value for that one over there. We then repeat the process and we get y equals to x plus the previous function, which was negative 2.0792. So negative 2.0792. And we got 2 over root 3. And the other point was negative 0.9245. Negative 0.9245. Again, we want to find the normal of this curve. So y equals to negative 1x, because the gradients, remember, are perpendicular. The one gradient is equal to 1. This gradient is perpendicular, so it's equal to negative 1, and that's where we get the negative 1 from. And substituting it in the negative 0.9245 equals negative 1. 2 over root 3 minus 0.9245, plus c. That's what we want to find. All right, so that's going to be almost a calculator. Again, negative 0.92. Keep your work spaced out as a hint, just to make sure that you don't lose track of it on a piece of paper. Don't squeeze everything, because that's where the error is coming. And c equals 0.2302. All right, negative 1, 0.2302 by the looks of this. Does it look correct? Is this a negative? Yeah, x is the same, and that's a negative as well. Good, so this is going to be y equals to negative 1x plus 0.2302. Let's see if that one's correct. So this also goes through a positive space here. Now I just sketched this, obviously this wasn't sketched properly. That means 90 degrees would actually go through there, and the tangent would actually go slightly tilted, would be below 1.77. So just like this diagram is not accurate, but not marked in this case. All right, so I got my normals now, and I've now answered the question. I've got my normals, I've got my two tangents, and the entire question was built on giving me a gradient and equation